Hey everybody, Tim Adams here. I'm all by my lonesome this time, but we're going to be talking about power systems and how they can interact with your AV systems. But before we get into that, um, it's going to be very important that I have this word of or disclaimer. I'm not an electrician. I don't pretend to be on radio or TV. Um, so if there are any questions in regards to your particular electrical system, it's always best to call a qualified electrician, fully licensed, bonded, and insured. At least that's the best you can get here in the States. So, having said that, I will attempt in the next little while to tackle one of the biggest and most complex issues um, that face AV systems today, um, and that is, where does hum and hiss come from, and what role does power play in in providing not only sufficient power that's clean, and we'll get into what that means later, um, but as well as reliable. So with that, we're just going to jump right in, and I'm actually going to pick up with hum. What causes hum in an audio system? And one of the primary culprits is what's called ground loops. And I'm going to be reading off of Wikipedia here as far as what a ground loop is, and then I'll further explain that. So, in an electrical system, a ground loop refers to a current, almost always unwanted, in a conductor connecting 2 points that are supposed to be at the same potential, often ground, but are actually at different potentials. So, a potential essentially is just an expected voltage, okay? And in a traditional wiring system, at least here in the States, we have a hot, we have a neutral, and we have a ground. Now, the idea is that the ground carries voltage away. That's at least my understanding of it. Unfortunately, the way that our systems are set up, according to the electrical code, there's usually more voltage on the ground than there's supposed to be. Now, without getting into a huge amount of technical discussion as to why that is, just essentially what a ground loop is, how to describe it is, I have a piece of equipment A, and that's plugged into a grounded outlet, electrical outlet over here. And then I have equipment B, and that's plugged into a separate electrical outlet. And those grounds on each outlet have different paths. Okay, they're not connected to the same ground, and that can produce what's referred to as a ground loop. And as far as audio systems are concerned, that is manifested largely by what we call a 60-cycle hum. And it's very noticeable because you've probably heard it. It's just a buzz. Not really so much a hum, but a buzz. Wah, really annoying. And they can be particularly difficult to track down because when you look at even the simplest of audio systems, you have many potential points that these ground loops can enter in. So allow me to refer to my notes. The other issue is that when you have wires that are being strung between, point A and point B, be it this distance or be it hundreds of feet, any hole or break in the wire's insulation turns that wire into an antenna. And we'll get into that in a minute, but I wanted to make sure that I pointed that out. But As far as dealing with, grounds and equipment and that kind of thing, I'm actually going to do a screen share here, if I can find the right thing. And we're just going to jump right into some of the solutions for ground loops. Now, first off, you have to isolate the ground loop, okay? And most of these, again, are going to be present in an audio system. So if you are hearing it in your audio system, the first thing to do is establish whether the noise is coming from before the mixer, the audio mixer, or after the mixer. Most often it will be coming before the mixer, or what we call downstream. So it could be coming in on a collection of channels. It could be coming in on just one channel. And it's very important to differentiate between whether it's one channel or whether it's all, or a selection, several channels. And the way that you do that is when you're hearing the buzz, you start taking the individual channel faders down, all the way down, and you're trying to isolate where that buzz is coming from. If it's one channel, great. Now you know that it's mostly isolated. If it's several channels together, and each time you bring the fader down on subsequent channels, it gets a little fainter, or when you bring them up, it gets louder and louder. That's more of an issue, okay? So we'll deal with both of these in turn, okay? So as you can see here, the first suggestion is group the cables involved in the ground loop into a bundle or a snake. And the idea here is we're trying to use any straight, or we're trying to basically use the concept of there is strength in many. So if there are any stray magnetic fields, okay, that are interfering, so say you have audio lines that are laying parallel to power lines, okay, and these are power cables that plug equipment in, okay? It doesn't have to be a big transmission line or an electrical cable that connects two panels together, electrical panels. It can be the smaller electrical cables that you plug equipment in with, okay? But if you're running those parallel within 3 feet of each other, then that's immediately where I would begin, just because every cable has a magnetic field that it transmits, if you will. Power cables are some of the worst. And generally speaking, if you're running signal cable, okay, so in this case it'd be a mic cable next to a power cable, that mic cable, while it does have shielding and it does have technologies built into it that will allow it to reject a good portion of electromagnetic interference, or EMI is what we call it, it's not perfect. And you need to do whatever you can to eliminate all EMI from getting into your sound system wherever you can. This is why you don't run them parallel, because, again, without getting too technical, you're just inviting EMI to get into your system. If you can't avoid running the cables near each other, then try to run them at 90 degrees, okay? So for example, if you have to cross a power cable with an audio signal cable, cross it at 90 degrees, and that way it's out of phase, and then run it at least 3 feet separation. You can run it in parallel as long as there's 3 feet of separation. That's kind of the standard rule of thumb. Okay, and this is more or less what this first one is getting at. Just by grouping the audio signal cables together, you're enhancing through addition, basically, the ability for that group of cables to reject EMI that may be entering in. So kind of like the biblical example of one thread may be easily broken, but a bundle of 3 or more is not, so easily broken. So the second one here, create a break in the signal cable shield conductor. And I want to bring up this graphic, and let's make sure that that's actually getting through. Okay, good, it is. So this is basically what we call a pinout diagram for how balanced XLR cables are terminated. Okay, this is the XLR connector that you guys are all so familiar with the 3 pins, and this will tell you where the cables. Okay, so in a standard audio cable, you've got 3 conductors, is what we call them. Okay, so you've got a positive, a negative, and the drain wire, which in this case would also be called the ground. And this is generally made up of what's called the shield. Okay, that's the strand, not stranded because it's not really stranded together, but there's a bunch of metal strands if you've ever opened up one of these cables. And that is meant to form part of that EMI rejection technology built into the cables. It's not perfect, but it does help. But when you terminate, you wind all of these separate strands together, and that becomes this cable here, the drain. And then you can see that goes to pin 1 on the connector. And again, I'm trying not to get too technical. I'm probably doing a horrible job of explaining this, but the idea is that pins 2 and 3, okay, they carry essentially the same signal, but they're different. Maybe they're slightly out of phase, but there is a differential between them, being that when, okay, so female, this is what you plug into, like your microphone, okay? And when that signal gets to the connector here, only one of those signals is going to actually get through, okay? And in the balanced case, which is what we're looking at here, this is the best way to wire audio signals, okay? This is the best connector to use. This is the best wiring scheme, simply because you have that kind of cancellation thing going on. Whereas the pinout for, say, a 1/4 inch connector or an 1/8 inch stereo jack connector is an unbalanced signal, and it's much easier for noise and EMI to get in there. So let's go back to more solutions here. So that's what they're talking about. So you would basically, on one end of the cable, okay, and what they call the load end, which I have to admit, I'm assuming is meaning the female connector here, you would actually not connect pin 1. And the reason for that is because if there is any signal getting in, any interference getting in, it's likely coming in on that cable. So if you break that, what they call breaking, if you just don't connect that, then that would likely help. It's, as you can see here, it's called ground lifting. So you're lifting the ground, you're taking it out of play, if you will. And as you can see here, a lot of equipment has ground lift switches, okay, at the inputs, which disconnect the grounds. Unfortunately, there is a problem with that because, as you can see here, it leaves that component ungrounded, which could cause a safety issue for the user. It could shock the user, but it could also introduce stray leakage currents because you're taking the ground out of play, and thus you're taking that the purpose of the ground out of play as well, which is to take that stray leakage current and dissipate it. They're also saying put a small resistor of about 10 ohms, that's what that omega signal stands for, in the shield conductor. Okay, now I understand that this is really technical here, but you would essentially be putting in this resistor between the cable Okay, so let's go back to our wiring diagram. Okay, so you'd be putting it in between this and the pin. Okay, and in this case, they're recommending that you're doing that in the cable shield conductor at the load end. Okay, so that would be on the female. Okay, and you put it between the drain wire and pin 1. And the purpose for that is the resistance in the resistor is large enough to stop that EMI current from getting in, but small enough to keep that that audio component grounded, which would prevent that loud hum. This is probably one of my favorite ideas here. Use a ground loop isolation transformer, and I'll just cycle through a few of them. They will be at different price points, so don't get scared by that particular one. Let me just drag this over here. Now, keep in mind, you get what you pay for. But as you can see, you know, they're kind of all over the place. I would be much more prone to trust this guy than something like that. But, you know, they do exist, and those would likely be kind of a last-ditch effort. But the other important thing is when you're troubleshooting and isolating, it's important that you learn to eliminate logically. Okay, so if you can narrow it down to exactly where it's getting in, okay, maybe it's getting in at a speaker, maybe it's getting in at the microphone. And generally speaking, what will happen is, by and large, excuse me, your hum is coming in at one of these connections. Okay, so one of these wires has gotten disconnected from one of these pins, and that's what's causing the hum to get into your system. So the good news is, for the most part, it can be an easy fix. The bad news is, when it's not, it can be a very time-consuming process to narrow down exactly what's causing it and where it's getting in. But having another mixer around to just remove the mixer and make sure it's not the mixer is a good idea to have. So, and I wanted to point this out right here. The opto isolators, okay? So this is essentially an isolation transformer for digital lines, okay? So a lot of people say, well, go to digital and you won't have to worry about hums and all this stuff. Well, that's not exactly true, because it's not necessarily inherent in the analog lines, while it can be. It's really an issue with the power system and how it's wired, as far as where the ground loops occur and why they occur. It's kind of an inherent issue with how our wires or our electrical system is wired. So what we're talking about is, you know, number one, isolating where it is coming in, and two, how to deal with that. Okay, and sometimes there's nothing you can do other than getting an electrician in there and fixing it, right? But you have to know that that's what the problem is. And so that's why we're talking about troubleshooting. And sometimes they won't be able to fix it. And so you're going to have to do something like get an isolation transformer, or in this case, an opto isolator. You've also probably seen these ferrite bead chokes. These are the large round tubes that clamp around power lines, or power cables, I should say. A lot of power cables that come with, say, printers and computers will actually have these permanently installed, just to help deal with some of these issues. So, but those chokes are not going to have a direct effect on what we're talking about, the 60 cycle ground loop hum. So hopefully that's giving you some ideas as far as ways that you can combat it. Let me also go to this page and, sorry, different page. So yeah, hopefully that helps define some things for you. Ground loops, they're nasty. They're really nasty to troubleshoot. They're really nasty to have in your system. And it's really important that your audio lines are terminated correctly. And you know, a lot of times it'll get in at the snake, for example. When you wire a snake, it's important that each individual cable, all right, has shrink wrap tubing coming out of the back of the connector, okay? And it's also important that when you open up the connector, and if you've ever opened up an XLR connector, it's pretty cool how they put it together. If not, look into it, it's awesome. But when you open it up, the other ideal is that how can I put this? Each terminator, or each conductor, there we go, each cable should have its own shrink wrap tubing to keep it isolated from the other conductors. And if it doesn't, that may be a sign that bad things are to come. That's not necessarily true. A good solder job and wire stripping will leave maybe 1/8 of an inch of exposed conductor wire, just enough to actually solder it to the pin, what we call the well, basically. So it's where the wire connects to the metal that extends out to the pin that you're seeing on the outside of the XLR connector, for example. And in which case there's actually insulation on each conductor to help isolate it. So just little tidbits for you. But let's move on to hiss. Hiss is another sometimes prevalent problem, common problem in audio systems. And it's important to understand that, first off, it doesn't matter if you have a $500,000 audio system or a $2,000 audio system. There's going to be a certain amount of inherent noise, okay, hiss, if you will, just in the fact that it's inherent in circuits. That's just the way it is. What differentiates whether you have a problem with hiss or not is what we call the signal to noise ratio, okay? And essentially that is indicated, okay? It's described with a decibel rating. So for example, a -90 dB signal to noise ratio is going to be much better than, say, a -20. Okay, and what this refers to is the noise that's inherent in all audio systems with all the circuitry and all the resistors and all that. Okay, that's that noise that it produces. Okay, is what we call the noise floor. Okay, now where we get the ratio is, let's say I'm talking on a microphone. How much signal can I expect between me talking on the microphone and that noise floor? That is the ratio, okay? Now, the higher the decibel number, the less you're going to hear of the noise floor and the more you're going to hear of the signal, which is good. That's what you want. However, you can have a really good signal to noise ratio on your equipment and you can still get a lot of hiss. And a lot of that has to do with improper gain structure. And what I mean by that is when you're on a soundboard, Okay, if you're anywhere near familiar with how a soundboard is set up, the very top you have what's called a gain or a trim knob. Okay, and if you have those cranked all the way up, okay, and your individual channel faders are riding fairly low, and you have your main faders all the way up or close to it, that's a bad gain structure. And the reason for that is because that gain knob is essentially taking the signal that's coming in from the microphone and it's artificially raising it, okay, because those connections on the back of your soundboard are called preamplifiers, okay, and they're really designed to operate with a trim or gain knob at 12 o'clock or, at the max maybe 75, okay, before it starts really introducing or bringing up that noise floor so that you can hear it. So if you're relying on the gain knob to get most of your signal and you're not relying on your faders, then you're artificially raising that noise floor to the point that you're going to hear at some point that noise floor in the form of hiss, okay? And you'll know it when you hear it. Essentially, it's not a problem until it starts to interfere with the experience of the listener, if that makes sense. So if I'm standing, 6 feet in front of or 6 inches in front of a speaker, and I'm hearing, okay, but I step back to 10 feet and I don't hear a thing, that's good. That's not a problem. If I'm 10 feet away, let's say, is the closest listening position, and I'm hearing it very audibly, that's a problem, okay? And that needs to be addressed. Now, we should be setting up our gain structures properly anyway, and here's how you do that. So, at your board, you turn all of your gain knobs down to 0, okay? And you take all of your faders, and you can do this one by one. It's probably a better way to do it. All the way up to the stops, okay? And you take your mains. And for me, I'm a little flexible. A lot of industry guys, they'll say crank your mains all the way to the top. Take your main faders all the way to the top. And then you're going to have somebody talking on that microphone, okay? Or if it's an instrument channel, playing on the instrument. And you're going to raise that gain knob to the point where the microphone starts to feed back, or the sound from the instrument starts to distort, okay? You're going to back the knob off about 10%, okay? Now you've properly set the gain for that channel because and we also call this ringing out the room, okay? You know that your faders all the way at the top, say on a microphone channel, are not going to produce feedback. Okay, so you're kind of killing 2 birds with 1 stone. So you do that to all of your channels. Okay, now you've set up proper gain structure. Now, here's the problem. If your fader's all the way up and you're cranking that gain knob, past, say, 75%, okay, so that'd be about the 3 o'clock position, and you're still not getting an acceptable signal, you have a problem. Okay, so it's either your preamp isn't strong enough to basically amplify that signal, or the microphone's not producing strong enough signal, something like that. Okay, that's really not a discussion for this forum, but we need to make sure that this is something that we're doing, and maybe we go through it twice a year. If you're in your own building, maybe once a month, once a quarter if you're a mobile church. Somehow we need to make sure that we're doing this on a somewhat regular basis, simply because acoustics can change on a weekly basis depending on how many people show up. And especially if you're a mobile church like we are at my church, the speaker positions get moved constantly depending on who's setting it up. from week to week. And so your gain before feedback is really going to change. But anyway, back to the topic. So that is the most common source of hiss. All right. As far as other sources, it's really hard to say. You could have a piece of equipment that is just producing a hiss that, you know, it's a malfunction, it's broken, it's not working properly. Again, follow your troubleshooting steps to isolate that. You know, basically, you take everything out, okay? So you take all your signals down, and one by one, you go through and you find which channel is producing that hiss or that hum, okay? And then you go from there. That's kind of the best case, the best advice I can give you in regards to that. Now, let's, oh, yeah, sorry. Two things. Some other common sources of hiss is over-amplification. Again, you're artificially raising that gain floor, or that noise floor, and overusage of compressors. This one actually surprised me. And again, without going too much into why compressors would create that, just realize that if you're getting hiss from your compressors, okay, and again, going through the troubleshooting, if you're finding it on a channel and it's not anything on the mic side or the cable side, then it's likely in the board itself. And if you have compressor capability in the board, or if you have it on as an outboard piece of gear, it's not going to hurt to try this, okay? So you set your threshold higher, okay? And those of you not familiar with compressors, you set a volume level, let's say, decibel level, no, not decibel level, volume level, for when the compressor begins to apply itself, okay? So let's say negative 24 dB, just arbitrarily, okay? Next in the step of compression is what's called the ratio, okay? So this is telling the audio or you're telling the compressor, okay, when you start applying yourself, I want you to apply a 3-to-1 compression ratio. So for every for every 3 elements of volume above the threshold, I want you to turn it down 1 element. So you have a net of 2, let's say, okay? So you set the threshold higher. So instead of negative 24, you set it to negative 18 or negative 12, right? And you lower the ratio. That's just the research that I've done. Give it a try. I'd love to hear if that works. I've not actually experienced myself hiss associated with compressors. So if somebody out there at any time, you know, this is 2014. So if it's 2019 and you try it and it works, I want to hear about it. Look me up. So the final thing that I want to talk about as far as issues with power in sound specifically is RFI, so radio frequency interference. And this is often manifested in your ability to hear a radio station through your sound system. It's never pleasant. I remember working at not working, but I was volunteering at a church in the video ministry, and we consistently, we had 3 hanging microphones that we'd use to just pick up instrumentation and choir and that kind of thing. We would consistently get an AM sports station and when we really cranked it up. And sometimes, you know, we were doing distance miking from probably double the distance we should have been. And so we had to crank the mics quite a bit to get any kind of acceptable intelligibility or levels. And we would get, you know, the sports station in there. And we never really knew what to do with it, honestly. And it can be a really, really annoying problem, honestly. And yeah, it's really disruptive. It's really distracting. Not to mention the potential copyright issues. So we need to do what we can to fight that. And let me get to this page, and we'll start talking about that. And I realize that the time is getting away from us, but let's do that one. All right. So, and I'll put links to all these pages on the event page so you guys can look it up later. So I like this guy's approach. This guy's name is Pat Brown. So it might actually be a guy, a gal. I don't know. So Pat Brown, if you're a guy or a gal, I apologize. And this term right here, divide and conquer, okay? And this again goes to troubleshooting, figuring out where it's getting in and then figuring out what to do about it, okay? So first off, again, start by dropping the levels of the main faders on your mixer. If the radio station goes away, you've localized it to somewhere in front of the mixer. Okay, so however, if it doesn't go away, unplug the rest of the outputs of the mixer from the rest of the system. Okay, so basically unplugging monitor sends or aux sends, unplugging the mains themselves, and that kind of thing. If unplugging the mixer stopped it, then the problem is the mixer or the devices connected to it. So that could be CD players, that could be iPods, iPhones, just basically any kind of a source. So now we're going to talk about the mic lines. Okay, now remember, this is where most of them come in for ground loops. So it makes sense that if that's the case, then also it would be a prime suspect for RFI, or that's the acronym for radio frequency interference. So again, drop the channel faders one by one. Okay, this is to identify where it's coming in, right? So if it's on channel 12 and all the other channels are fine, then obviously the problem is with something with channel 12. Okay. However, if the interference drops a little at a time with each channel, you may have some more serious issues. Okay. So Pat suggests that you run each mic line, or you listen to it through a headphone amplifier if you have one. And like he says here, you may need an external fan and power supply for condenser mics. But if they're clean through the headphone amp, then the RFI is through the mixer. Okay, in which case the mixer input may not be grounded properly or may not be RFI immune. So what that means is, again, going back to here, it's not grounded properly on pin 1, okay? And that you would need to look at that. It's also possible that the mixer itself is not grounded properly, as far as at the electrical outlet. So you may want to bring in an electrician to look at that, or if you have a facilities person at the church, have them look at that. So that's how you deal with mic lines, okay? If it's the mixer, okay, turn it. The RFI will either get better or get worse or stay the same, okay? If it changes the level, if it gets better or worse, then it's an issue with the mixer and you want to contact the manufacturer, especially if it's under warranty. If it's not under warranty, you'll probably want to look up some local repair place, or if you're out in the boondocks, you may want to figure out who is the closest repair shop to you and give them a call, see what they say. But before you send it off, make sure you find a replacement, because you don't want to be running without a sound system. I'll let you guys read this. This is where it starts to get a little over my head. But essentially it's, are there too many grounds between the mic lines and the power? So that is kind of the basics of troubleshooting RFI. Whoops. Let me bring that back up. And I'll bring myself back up here. So hopefully that's helpful. Like I said, it's a very distracting problem. It can be really irritating to both the operators and the audience. So the faster and the sooner that you can deal with that and get rid of it, the better off everybody's going to be. So that kind of covers the hum and the hiss and the RFI issues. But while we're talking power, I think it's also important to talk about when you're looking at upgrading equipment, especially lighting equipment, it's important to know how much power you have available. And the best example I have of this is a recent church that I did an install for. They wanted to put up 2 projectors and basically get a projection system going. So I put everything in, everything was hunky-dory, and then the first weekend came around, they ran it, and they had no end of problems. Okay, so the signal kept blanking out, which is really weird to me. And so I go back during the week, and this went on for like 8 months. So I go in during the week about once a month, and the system would work perfectly fine. I could not replicate their problem. And so I did probably 20, 30 hours of research trying to figure out what was going on. And what I kept coming back to was some people had issues in a home environment with an HDMI extender system. So essentially when a large appliance would turn on, say the furnace or the AC, the projection system would lose signal, or the HDMI extender system would lose signal. And so I started questioning, okay, I was working directly with the pastor. I said, okay, we need to make sure next time I'm in, okay, that everything that's on in the building is turned on. And we did that, and it still worked fine. And then on a whim, I asked him to make sure the furnace was on. The second he turned that on, signal went out. So the problem was that they had one building, one 200 amp breaker, or basically 200 amp service to the building, one panel, and everything was being powered off of that one panel. And as soon as that furnace kicked on, it pulled enough juice out of the availability of it. Somehow that interfered with the extender system, and we had a non-functioning system. Now, as a system integrator, as a designer, that's not something that I can predict. Okay, I just want to put that out there. But it's very important to understand what the power draw of new equipment is going to be in regards to, or in comparison to what the current power draw is right now. And I'd say large buildings, you're probably fine, but don't assume that you are. It pays to do the research, and this example, this story I just told you is a prime example of why it's important to do that. So again, just find out how much power do you have available, what's that headroom, so that you're not running into issues like I ran into and you're chasing your tail for 8 months. But yeah, like I said, especially lighting and audio amps. Okay, so those are 2 of kind of the largest power draw pieces of equipment that you're going to have. LEDs, even some of the newer LEDs, they're running into the hundreds of watts, and that's not nothing, so you need to think about that. The other thing I wanted to talk about was power conditioners. Not a lot of people understand what these are, and essentially some people call them glorified power strips. Well, okay, yeah, they have multiple outlets on the back, okay, and they do provide power to those outlets. So in that respect, yes, they are a power strip. However, most people don't understand that our electrical system has fluctuations, okay? So sometimes it's providing 125 volts, sometimes it dips below that. You get a lightning strike, you get a huge power surge through the electrical grid. or at least the electrical system in the building that's hit. Now, if everything's properly grounded and everything functions the way that it's supposed to, that's not supposed to damage your equipment. But with the prevalence of ground loops and, shall we say, some shady practices on the parts of some electricians, it's not really safe to assume that your building is wired correctly. I'm just going to say it. So that doesn't mean that it's not. I just am saying it's better for everybody if you don't assume that it is. So much like a battery backup, say in a mission critical situation, provides power for long enough to properly shut things down, okay, which I would advise for your AV systems. I would also strongly advise you get power conditioners, simply because if you get a huge voltage surge, okay, in the form of, say, a lightning strike, or you get these fluctuations, okay, the AV equipment that's coming out these days is so sensitive to stuff like that. I mean, obviously the HDMI extender system, very susceptible to fluctuations in the power system. So it's important that you provide clean, safe, reliable power to your equipment, if at all possible. These things are under $100, depending on manufacturer. It's a cheap insurance policy, and just like a really good surge protector for your home, it will sacrifice itself, which for under $100, that's a lot cheaper to replace than a $2,000, $3,000, $4,000 or more mixer or video switcher or amplifier, or, I mean, take your pick of line of AV equipment. So, you know, the cons, those are kind of the pros. The cons are that, you know, battery backups especially can have pretty large upfront costs. But I think you have to weigh that against what would it cost us to replace the equipment that's connected to it. You know, that's kind of the big thing with your home computer. If your hard drive fried, you know, some of those files are irreplaceable. Memories of a once-in-a-lifetime trip to Australia, or files that have taken you know, years to create, gone. Honestly, for $30 for a really good surge protector, it's worth it. So the final thing that I want to talk to you guys about, and you'll have to forgive me, I have to pull this diagram up. I wasn't able to get it pulled up prior, but is power sequencers. And these are just ridiculously cool pieces of equipment. And what it does essentially is it provides you the ability to turn either a key or flip a switch, and it will in turn turn on in sequence a selection of outlets on the back of it. Okay, so the most immediate benefit would be in an audio system turning on a audio mixer before the amplifiers turn on, to avoid getting that pop in the speaker system. All right, so let me transfer this over and I'll pull it up for you guys. The other capability is that you can actually connect sequencers together in such a way that one sequencer controls another sequencer, and I'll show you an example of that here in a second once I get this set up. Oh, all right, so I am going to switch over to a screen share shot here, and there it is. This is a diagram that I did showing how the power is connected. And I'll go ahead and zoom in here in a second. But just understand that this stack of equipment, okay, and this equipment on the bottom is separated by like 100 feet. So let me just jump in here. So I'm trying to highlight the sequencer here. So the sequencer is right here. Okay, so you got one button. I'm trying to find my hand tool. I'm not really succeeding at it. Oh, there we go. Okay. So this is the sequencer here. Okay, and it has 6 outlets on the back separated into what they call 3 pods. Okay, and each pod is turned on in sequence as soon as this switch is flipped. Okay, so that will power the units, power on or provide power for, you know, this equipment here, for the mixer, and for the equipment over here. Okay, so this is a CD player with an iPod connector. This is a Blu-ray player, and this is obviously a laptop. So, but what's important to realize here is this little line right here. Okay, so we'll scroll up. This is a connection, okay, all the way over to this guy, okay, which exists in the back of this rack, okay? And right here, we have power conditioners, okay? And they call it power distribution. And then all the rack equipment is connected to these guys, okay? And these guys are connected in turn to these outlets, okay? So right here is the connection for the sequencer from the front, okay, which automatically tells this which pod, okay, we'll go all the way back here, okay, so which pod on this sequencer is going to activate these pods, okay? So each collection of outlets here, each 2 outlets is a different sequence. So sequence 1, sequence 2, sequence 3, sequence 4, okay? So that's essentially what a sequencer allows you to do. And you can get really complex systems. You can have, you know, a dozen sequencers turning everything on in sequence, which is really cool. Being able to have one power switch to control the power for your entire system is, I mean, it's mind-blowing to me where technology is taking us. So that is kind of where everything is at right now. I'm going to go ahead and cycle through the event pages, or the event page, to see if anybody's asked any questions. Doesn't look like it. Okay, so that's good, I guess. Oh, hi, Aaron. Good to see you. He's on mobile. I'll just cue him up here. There he is. Wave for everybody, Aaron. There you go. He's driving, so I'll let him drive. Yeah, exactly. So I am very thankful for everybody that's watching. Looks like we got 2 viewers. Again, I apologize for being by myself. That's just the way it turned out this evening. But hopefully you've gotten some useful information. And again, if you have any questions, feel free to ask on the event page or in the relevant Google Plus group or community that you are a part of. This was advertised out to the Church Tech, Adventist Church Tech, Tech Applied, and Church Mag groups. So ask away in there. I surf to all of them. So you can also reach me directly on Google Plus. Put me in a circle. I'll add you back. Promise. So, Aaron, just nod yes or no. Do you have any questions? No? Okay. Excellent. Well, in that case, I'm going to call it a night. And thank you for watching. Again, hopefully you got some useful information out of it. And again, I just want to make it clear, I'm not an electrician. There are people who know a lot more about 60 cycle hum, ground loops, radio frequency interference, electromagnetic interference, that can tell you if a signal or interference is coming in via induction, if it's capacitive, if it's radiative. I mean, there's all sorts of different ways that interference can get into your system. I think the key to remember is that it's trying to get into your system, okay? And you are a warrior, if you will. You're a bodyguard for your AV system. And you need to take that seriously. Unfortunately, a lot of times you're not going to know that it's in your system until it manifests itself, you know, in either a hiss, a hum, or a buzz, something like that, or, you know, an actual radio station. Or maybe a wireless microphone is just stops to work, or, you know, stops working because it's getting overloaded with interference from a digital television station. And maybe we'll talk about that next week. I don't know, the new FCC stuff that's going on. So, oh, one other thing I completely forgot. Ground loops can manifest themselves in video systems, and that's not something that a lot of people know. If you are familiar, and I'm sure that you've seen it, it shows up as black scrolling horizontal lines. Okay, and again, that has to do with different components being plugged into different electrical outlets that have different paths to ground. Okay, that's where it connects to our topic as far as power in church. So I have a church in Las Vegas right now that is dealing with a system that's doing that. So it's very difficult to track down. They were able to get rid of it temporarily by unplugging a piece of equipment. So it's exactly right. You know, figuring out your electrical system issues now instead of later is only going to serve you better in the long run. So with that, God bless. Thanks for watching, and we will see you next week.